Now, in this lecture, we will find out the length of line segment X. In the drawing, we have an hexagon, and we know that one side of this hexagon is equal to 2 units, line segment PB equals to 3 units, and our mission is to find out the length of line segment PA that is equal to X. So, first of all, so this is a regular hexagon, and we know that an hexagon it is actually a polygon with 6 sides that are equal to each other. The sides here, 1, 2, 3, 4 sides, and so all of its sides are equal to each other. That is to say, side AB equals to side BC equals to side CD equals to side DE equals to side EF. So, and because of the fact that one side is given us the equation that one side of this polygon equals to 2 units, therefore all the other sides are also equal to 2 units. So FA equals to 2 units, EF equals to 2 units, ED is also equal to 2 units, DC equals to 2 units, and BC is also equals to 2 units. And all of its angles are equal to each other. This polygon has 6 angles that are 1, 2, 3, 4, 5, 6 angles. Okay? And all the angles are equal to each other. Okay? What is the sum of the angles in any polygon or in any hexagon that is a regular hexagon, this regular hexagon, or in any hexagon? Actually, any hexagon is composed of 2 quadrilaterals. Here, for example, this is an hexagon. Okay. This is an hexagon. A, B, C, D, E, F. If we join points E and B together by a straight line, by joining points E and B, we created here 2 quadrilaterals. Quadrilateral ABFE and quadrilateral BCED. And we know that the sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of the angles in quadrilateral ABFE is equal to 360 degrees, and the sum of the angles in quadrilateral ABCEBCD is also equal to 360 degrees. Therefore, the sum of the angles in those 2 quadrilaterals, that is the sum of the angles in the hexagon, will be equal to 360 degrees plus 360 degrees, that is 720 degrees. Okay? So, actually, the sum of the angles in this regular hexagon, it is equal to 720 degrees, and this regular hexagon consists of 6 angles that are equal to each other. Here, all those 6 angles, they are equal to each other in their sizes, and because of the fact that the sum of those 6 angles in total, they are equal to 720 degrees, if we define the size of one angle as x, or if the sum of the angles in this regular hexagon is 720 degrees, and we have 6 angles that are equal to each other, it means that the size of one angle will be equal to 720 degrees over 6. That is actually 120 degrees. So we actually found out that each angle here, it is equal to 120 degrees. Okay, so I repeat again that in any regular hexagon, all of its sides are equal to each other. Here, all the sides of this regular hexagon are equal to 2 units, and all of its angles are equal to each other. That is to say, each angle equals to 120 degrees. In total, the sum of the angles in regular hexagon is equal to 720 degrees, and each angle equals to 180 degrees. So in the next step, we will do a construction. We will extend side DC of this regular hexagon by a straight line. DC is one side of the regular hexagon, and as a side of a regular hexagon, DC is absolutely a straight line. Then we extended the straight line DC by a straight line. Therefore, if this we define this point as L. Therefore, DL, when you extend the straight line by a straight line, the result is a straight line. We extended the straight line DC by a straight line. We got DL, that must be also a straight line. We extend the straight line by a straight line, the result must be a straight line, therefore DL is a straight line. Here, DL, line segment DL is a straight line, and we also know that according to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line DL at point C, here the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at this side of the straight line DL at point C? We have this angle that is equal to 120 degrees. Plus the missing angle, in total, they must be equal to 180 degrees according to rule number 1. Therefore, this missing angle must be equal to 60 degrees in order to complete the sum of the angles on this side of the straight line DL to 180 degrees. This angle must be equal to 60 degrees. Okay, so angle BCL equals to 60 degrees according to rule number 1. In the next step, from point B, we will draw perpendicular on the extended DC, or we draw perpendicular from point B on DL. So this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. Okay. we define the touching point of the perpendicular from point B in the extended DC as M. By doing this construction, we created here the right triangle, triangle CBM. In this right triangle, triangle CBM. So I will copy the right triangle CBM in a new page and we'll analyze it. So actually, this is the right triangle CBM or CMB that I copied from the original drawing. CB equals to 2 units. It is one side of this regular hexagon, therefore it is equal to 2 units. We just right now found out that this angle equals to 60 degrees according to rule number 1. So in this triangle, triangle CMB, cosine 60 degrees equals to CM over CB. Okay, cosine 60 degrees equals to CM over CB. So it is equal to CM over CB, and CB equals to 2 units, so we substitute CB by 2. Cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2. 1/2 equals to CM over 2. CM over 2. Here we will multiply this equation by 2 and we'll get that CM equals to 2 over 2, that is 1. So we found out that CM equals to 1 unit. Here we can write down that CM equals to 1 unit. Likewise, sinus 60 degrees in triangle CMB, sinus 60 degrees equals to BM over CB. Okay, sinus 60 degrees equals to BM or MB, doesn't matter, over CB. So sinus 60 degrees equals to BM over CB. CB equals to 2, so we substitute CB by 2. Sinus 60 degrees, it is equal to square root of 3 over 2, so we substitute sinus 60 degrees by square root of 3 over 2, and it is equals to BM over 2. Here we will multiply this equation by 2, and we'll get that BM equals to the square root of 3 units. Here BM equals to the square root of 3 units. You can write down here that BM equals to the square root of 3 units. Okay. In the next step, we'll focus on the right triangle, triangle PBM, this right triangle. So I will copy the right triangle PBM in a new page and we will analyze triangle PBM. is the right triangle PBM, because this angle equals to 90 degrees. So here PM B CM equals to 1 unit. PC, we don't know what is the length of PC, so we will define line segment PC as A, and in total PM equals to PC plus CM. Again, PM equals to PC plus CM, that is to say PM equals to A plus 1. We have already found out that BM equals to the square root of 3 units. And it is given us the question that PB equals to 3 units. So actually, this is the right triangle PBM that I copied from the original drawing. Here we will implement the Pythagoras theorem on this right triangle PBM in order to find out the value of A. So here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. In this right triangle PBM or PMB, the hypotenuse is PB, this is the hypotenuse, therefore the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to PM squared plus BM squared. Okay, so we found out that according to the Pythagoras theorem, in the right triangle PBM, PB squared equals to PM squared plus BM squared. PB equals to 3 units, therefore PB squared is 3 squared, that is 9, and it is equal to PM squared. PM equals to A plus 1, therefore PM squared equals to A plus 1 squared plus BM squared. BM equals to the square root of 3 units, therefore BM squared it is the square root of 3 square, square root of 3 square. So in conclusion, we found out that 9 equals to A plus 1 square, and the square root of 3 square is 3 because there is 2 opposite functions that cancel each other, and we're left only with 3. Here we will subtract 3 from this equation, and we get that 9 minus 3 is 6, so 6 equals to A plus 1 squared. Here we'll take a root out of this equation, and we'll get that the square root of 6 equals to A plus 1. Here we'll subtract 1 from this equation, and we'll get A, the missing variable, equals to the square root of 6 minus 1. Okay, A equals to the square root of 6 minus 1. So we can write down here that in our original drawing that A equals to the square root of 6 minus 1 units. Okay, so in the next step we will join points A and C together by a straight line. By joining points A and C, we actually created here triangle ABC. This is triangle ABC. Repeat again. This is triangle ABC. So I'll copy triangle ABC and we'll implement the law of cosines in this triangle ABC. Okay. CB equals to 2 units. Side CB equals to 2 units. And side AB is also equal to 2 units. Those two sides are the sides of the regular hexagon, and all the sides of a regular hexagon are equal to each other. Therefore, each side equals to 2 units. And this angle is one angle out of the 6 angles of the regular hexagon, and we know that all the angles inside the regular hexagon are equal to each other. That is to say, this angle equals to 120 degrees. Okay. So this is triangle ABC that I copied from the original drawing. So we will implement here the law of cosines. I remind you what is the law of cosines. We have here, this is triangle M and C, and this is angle theta, and we know that the length of side MN is A units, the length of side MC equals to A units, side MN equals to B units in its length, and side CN equals to C units in its length. Then, according to the law of cosines, in this triangle ABC, that could be any triangle, C squared, that is the length of side CN, equals to A squared plus B squared minus 2 times A times B times cosine theta. It is true in any triangle. So we can implement this law, the law of cosines, in our triangle ABC, in order to find out the length of side AC. According to the law of cosines, the length of side AC squared, equals to AB squared plus CB squared minus 2 times AB times CB times cosine 120 degrees. Okay, so AC squared, this is the line segment that we are looking for, or the side that we are looking for, equals to AB squared. AB is 2, therefore AB squared, it is 2 squared, that is 4. plus CB squared, CB is 2, therefore CB squared is 2 squared, that is 4, minus 2 times AB is 2, times CB it is also 2, times cosine 180 degrees, the value of cosine 180 degrees is minus 1/2, minus times minus is plus, so this expression in total will be a positive number. 2 over 2 is 1, and 2 times 2 is 4. So in total this expression equals to 4. In conclusion, found out that AC squared equals to 4 plus 4 plus 4. 4 plus 4 plus 4 is 12. Here we substitute 12 by 4 times 3, so AC squared equals to 4 times 3. Here we take a root out of this equation and we get that AC equals to the square root of 4 times 3. The square root of 4 is 2, so we can take 4 out of the root. And in conclusion, we get that AC, the line segment that we are looking for, equals to 2. Inside the root, we left only 3. AC equals to 2 times square root of 3 units. Here we can write down that AC equals to 2 times square root of 3 units. So we'll continue. Here we know that this angle equals to 120 degrees. But if we focus on triangle ABC, this angle equals to 180 degrees. So I'll copy again triangle ABC. So this is triangle ABC that I copied from the original drawing. We know that the sum of the angles in any triangle is equal to 180 degrees. Side AB equals to side BC. And we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, those two angles are equal to each other. So if one angle equals to x, then the other angle must be also equal to x. And the sum of the angles in this triangle, triangle ABC, equals to 180 degrees. So 120 degrees plus x, in total must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we'll subtract 120 degrees from this equation, and we get that x plus x, that is 2x, it is equals to 180 degrees minus 120 degrees, it is 60 degrees. So 2x equals to 60 degrees. We divide this equation by 2, and we get that x equals to 30 degrees. So here, this angle equals to 30 degrees, and this angle also equals to 30 degrees. Okay. So here angle ACB, this angle ACB equals to 30 degrees. So actually angle PCB that is equal to 120 degrees minus this angle, that is angle ACB, that is equal to 30 degrees, equals to the missing angle, that is angle ACP, this angle. Repeat again, angle PCB minus angle PCB that is equal to 120 degrees minus angle ACB that is equal to 30 degrees equals to angle ACP. Okay, so angle PCB equals to 120 degrees minus this angle ACB that is equal to 30 degrees. 120 degrees minus 40 degrees, it is 90 degrees. So in conclusion, we found out that angle ACP equals to 90 degrees, that is to say it is a right angle. We found out actually that this angle, it is a right angle. Okay? Angle ACP, this angle equals to 90 degrees, it is a right angle. Okay, so we focus on the right triangle because of the fact that angle ACP is a right angle, therefore triangle ACP is a right triangle. Therefore we can actually implement the Pythagoras theorem of the right green triangle, triangle ACP. Okay. In the right triangle, triangle ACP, so I'll copy the right green triangle, triangle ACP in the new page, and we'll implement the Pythagoras theorem on the right triangle ACP. So okay, this is the right triangle, triangle APC that I copied from the original drawing. We just right now found out that AC equals to 2 times square root of 3 units. We have already found out that PC that is equal to 8 is equal to the square root of 6 minus 1 unit. And we have the missing hypotenuse AP that is equal to X. That is what we have to find out in this question. So we'll implement here the Pythagoras theorem in order to find out the length of the hypotenuse AP that is equal to X. By PT is the relation for Pythagoras theorem. In any right triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle APC is AP, therefore the square of the hypotenuse is AP squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to AC squared plus PC squared. Okay. AP equals to X, therefore AP squared is X squared. Our mission is to find out the value of X. By solving the equation here, we find out the value of X. So X squared equals to AC squared. AC equals to 2 times square root of 3 units, therefore AC squared equals to 2 times square root of 3 square plus PC square. PC equals to the square root of 6 minus 1 unit, therefore PC square equals to the square root of 6 minus 1 square. So X square equals to the square root of 2 times square root of 3 square. It is actually 4 times 3, 2 square is 4, square root of 3 square is 3. 4 times 3 is 12. So this expression in total equals to 12 plus square root of 6 minus 1 square according to the algebraic identity, that the square root of a minus b square equals to a square plus b square minus 2ab, we get that square root of 6 minus 1 square equals to the square root of 6 square, that is 6, plus the square root of 1 square, that is 1, minus 2 times the square root of 6 times 1, that is square root, or minus 2 square of 2 minus 6. So x square equals to 12 plus 6 is 18, 18 plus 1 is 19, minus 2 times square root of 6 units. Here we take a root out of this equation and we get that x equals to the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, it is equals to 3.755 units. Okay, that is the answer to the question. Yeah, the length of side AP that is equal to x, it is equals to 3.755 units. Okay. In the next step, I will summarize the lecture. So, in the drawing, we have a regular hexagon. A regular hexagon is a polygon that has 6 sides. 1, 2, 3, 4, 5, 6. And in a regular hexagon, all the sides are equal to each other, and also all the angles of all the 6 angles are also equal to each other. And what is the sum of the angles in any regular hexagon? So if this is an hexagon, if we join points A and B together by a straight line, in this way we'll create 2 quadrilaterals. This ABEFE is a quadrilateral, and BCED, this is also a quadrilateral. And we know that the sum of the angles in any quadrilateral is equal to 360 degrees. So that is to say, the sum of the angles in quadrilateral ABFE is equal to 360 degrees. And also the sum of the angles in this quadrilateral BCED is also equal to 360 degrees. And therefore the sum of the angles in total those 2 quadrilaterals is 360 degrees plus 360 degrees, that is 720 degrees. So in conclusion, we actually found out that the sum of the angles in this regular hexagon, it is equal to 720 degrees. But because of the fact that in any regular hexagon all the angles are equal to each other, therefore if the sum of the 6 angles in any regular hexagon it is equal to 720 degrees, it means that the side of one angle must be equal to 720 degrees over 6. 720 degrees over 6 is 120 degrees. So we actually found out that each angle here, it is equal to 120 degrees in its size. Okay? In the next step, we extended side DC by straight line, and then this point L. And in the next step, we actually found out the size of this angle by extending DC by straight line, DC is one side of the regular hexagon, therefore it is absolutely a straight line. And when you extend the straight line by straight line, the result is a straight line. So DL must be also a straight line. So if you focus on this side of the straight line DL at point C, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees, the sum of the angles in this side of the straight line PL at point C must be equal to 180 degrees. So which angles we have here? This angle equals to 120 degrees. Plus the missing angle, in total they must be equal to 180 degrees. Therefore this missing angle must be equal to 60 degrees. In order to complete the sum of the angles on this side of the straight line PDL to 180 degrees at point C to 180 degrees, the missing angle must be equal to 60 degrees. So this angle BCM equals to 60 degrees in its size. Then from point D we draw perpendicular on the extended DC, or from point B we draw perpendicular on DL. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Okay, we defined the touching point of the perpendicular from point B and DL as M. By doing this construction, we get the triangle, the right triangle CMB. In the next step, we implemented the Pythagorean theorem on this right triangle CMB or CBM. This is the right triangle CMB that I copied from the original drawing. We just right now found out that this angle equals to 60 degrees. This angle equals to 90 degrees according to our construction. And BC is one out of 6 sides of the regular hexagon that is equal to 2 units. Why? Because all the sides of a regular hexagon are equal to each other. So if one side equals to 2 units, then all the other sides of the regular hexagon must also be equal to 2 units. Okay. Here, cosine 60 degrees in the right triangle CMB equals to CM over CB. It is the side near the angle over the hypotenuse CB. The side near the angle is CM and the hypotenuse is CB. So cosine 60 degrees equals to CM over CB. So it is CM over CB equals to 2 units. So we can substitute CB by 2 so cosine 60 degrees equals to CM over 2. Cosine 60 degrees equals to 1/2. So we can substitute cosine 60 degrees by 1/2. So 1/2 equals to CM over 2. Here we multiply this equation by 2 and we found out that CM equals to 1 unit. Here CM equals to 1 unit. You can write in the original drawing that CM equals to 1 unit. Okay, then sinus 60 degrees equals to the length of the side that is in front of the angle, that is actually BM over the hypotenuse BC. So sinus 60 degrees equals to BM over BC or CB. So sinus 60 degrees equals to BM over CB is 2, so we substitute CB by 2. And sinus 60 degrees equals to the square root of 3 over 2. So we can substitute sinus 60 degrees by square root of 3 over 2. And it is equals to BM over 2. Here we multiply this equation by 2 and found out that BM equals to the square root of 3 units. Here BM equals to the square root of 3 units. And here we go down in the original drawing that BM equals to the square root of 3 units. Then we focused on the right triangle PBM. This is the right triangle PBM. So I copied the right triangle PBM in a new page. Here CM equals to 1 unit and PC, line segment PC is unknown. So we define line segment PC as A. Line segment PC equals to A units in its length according to our definition. And therefore in total PM will be equal to PC plus CM. That is to say it will be equal to A plus 1. And BM equals to the square root of 3 units, and PB equals to 3 units according to what is given as the question. Okay, I repeat again. PM equals to A plus 1. BM equals to the square root of 3 units. This angle equals to 90 degrees according to our construction. And PB equals to 3 units according to what is given as the question. So we implemented the Pythagoras theorem on this right triangle PMB. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle PMB is PB, therefore the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to PM squared plus BM squared. So in conclusion, according to the Pythagoras theorem, in the right triangle PMB, PB squared equals to PM squared plus BM squared. PB is 3, so PB squared is 3 squared, that is 9, and it is equal to PM squared. PM is A plus 1, therefore PM squared is A plus 1 squared plus BM squared. BM is the square root of 3 units, therefore BM squared is the square root of 3 squared. So 9 equals to A plus 1 squared plus the square root of 3 squared is 3. So 9 equals to A plus 1 plus 3. We subtracted 3 from this equation and found out that 9 minus 3 is 6, so 6 equals to A plus 1 squared. Here we took a root out of this equation and found out that the square root of 6 equals to A plus 1. Here we subtracted 1 from this equation and found out that A, the missing 9/7 A, equals to the square root of 6 minus 1 units. So we can write here that the missing 9/7 PC, that is equal to A, according to our definition, it is equal to the square root of 6 minus 1 units. Okay, then we focused on, we actually joined points A and C together by a straight line. And we actually joined, we joined points A and C together by a straight line. And we focused on triangle ABC. This is triangle ABC. We know that AB equals to 2 units. This is one side of the regular hexagon. We found out that BC equals to 2 units also. Okay. And AC, we don't know what is the size of AC. And this angle equals to 180 degrees because it is 1 out of 6 angles of the regular hexagon, and all the angles are equal to 120 degrees. So I copied a triangle ABC here, and we implemented here the law of cosines. What is the law of cosines? If we have triangle MNC, that would be any triangle. The length of side AC is A units, side MN equals to B units in its length, and side CN equals to C units in its length, and this angle is angle theta. Then C square, C is the length of CN, C square equals to A square plus B square minus 2 times A times B times cosine theta. We actually can implement the law of cosines in our triangle ABC because the law of cosines is true in any triangle. So, according to the law of cosines, in our triangle ABC, AC square equals to AB square plus CB square or BC square minus 2 times AB times CB times cosine 120 degrees. This equation is the implementation of the law of cosines in our triangle ABC. So AC square equals to AB square. AB equals to 2 units, therefore AB square is 2 squared, that is 4. Plus CB square. CB equals to 2, so CB square equals to 2 squared, that is 4. Minus 2 times AB is 2, times BC it is also 2, times cosine 120 degrees. And the value of cosine 120 degrees is minus 1/2. So in conclusion, we found out that this expression minus 2 times ABC cosine 120 degrees equals to minus 2 times 2 times 2 times minus half. So AC square equals to 4 plus 4, and this expression, 2 over 2 is 1, and minus times minus is plus. So in total we have here 2 times 2, that is 4. So in conclusion we found out that AC squared equals to 4 plus 4 plus 4, that is 12. So AC squared equals to 3, and then we substituted 12 by 4 times 3, so AC squared equals to 4 times 3. And then we took out of this equation and found out that AC equals to the square root of 4 times 3. We took 4 out of the root, why? Because the square root of 4 is 2. So in conclusion we found out that AC equals to 2, inside the root we left only with 3. So AC equals to 2 times square root of 3 units. Here AC equals to 2 times square root of 3 units. You can write here also that AC equals to 2 times square root of 3 units. Then we focused on triangle ABC. In triangle ABC, this angle equals to 180 degrees because it is 1 out of 6 angles of the regular hexagon, and all the angles of the regular hexagon are equal to each other. They are equal to 180 degrees, each one of them. But we also know that AB equals to BC equals to 2 units. And according to the rule that in front of equal sides in the triangle there are equal angles, it means that those 2 angles that are located in front of equal sides must be equal to each other. So if this angle is x, then this angle must be also equal to x. Okay, so those 2 angles are equal to x degrees, each of them. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on triangle ABC, the sum of these angles must be equal to 180 degrees. So which angles this triangle has? It has x 180 degrees plus x plus x. 180 degrees plus x must be equal to 120 degrees plus x must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we subtracted 120 degrees from this equation and found out that x plus x, that is 2x, equals to 180 degrees minus 120 degrees, it is 60 degrees. So 2x equals to 60 degrees. Here we divided this equation by 2 and found out that x equals to 30 degrees. So this angle equals to 30 degrees and this angle also equals to 30 degrees. Then, so here, this angle ACB, equals to 30 degrees. But we know that angle PCB, this angle equals to 120 degrees because it is 1 out of 6 angles of the regular hexagon, and each of them is equal to 120 degrees. So we know that angle PCB equals to 120 degrees. Angle ACB, this angle equals to 30 degrees. Okay, therefore angle PCB, the big angle minus the small angle ACB, must be equal to angle PCA. The missing angle PCA. I repeat again. The big angle PCB minus the small angle ACB must be equal to the missing angle ACP. And this is the missing angle ACP. So PCB is 120 degrees, ACB is 30 degrees. Therefore, the missing angle ACB equals to 120 degrees minus 30 degrees, it is 90 degrees. So this angle ACP is a right angle, therefore the green triangle ACP is a right triangle. Okay, so I copied the right triangle ACP in an equation, we implemented the Pythagoras theorem in the right triangle ACP. Here AP equals to x, this is the line segment that we are looking for. We have already found out that AC equals to 2 times square root of 3 units, and finally PC equals to the square root of 6 minus 1 units. So this is the right green triangle APC that I copied from the original drawing. I repeat again, AC equals to 2 times square root of 2 times square root of 3 units. This is AC. PC equals to the square root of 6 minus 1 unit, and AP is the missing line segment. It is equal to x. Okay, and there this angle equals to 90 degrees according to what we have found out just right now. So triangle APC is a right triangle. We created the Pythagoras theorem on the right triangle, triangle APC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. The hypotenuse in the right triangle APC is AP, therefore the square of the hypotenuse is AP squared. It must be equal to the sum of the sides of the perpendiculars. That is to say, it must be equal to AC square plus PC square. AP is x, therefore AP square is x squared. And it must be equal to the sum of the sides of the perpendiculars. That is to say, it must be equal to AC square. AC equals to 2 times square root of 3, therefore AC square equals to 2 times square root of 3 square plus PC square. PC is the square root of 6 minus 1, therefore PC square is square root of 6 minus 1 square. So in conclusion, we found out that x square equals to 2 times square root of 3 square. 2 square is 4 and square root of 3 square is 3. 4 times 3 is 12. So in total this expression equals to 12 plus square root of 6 minus 1 square. We open the brackets according to the rule that a minus b square equals to a square plus b square minus 2 times ab. Okay, a is square root of 6 units, b is 1. So a square is square root of 6 squared, it is 6, plus b squared, it is plus 1 squared, it is 1, minus 2 times square root of 6 times 1. In conclusion, we found out that x squared equals to 12 plus 6 plus 1 minus 2 times square root of 6 units. So x squared equals to 12 plus 6 is 18, and 18 plus 1 is 19. In conclusion, we found out that x squared equals to 19 minus 2 times square root of 6. Here we took a root out of this equation, and we found out that x squared equals to the square root of 19 minus 2 times square root of 6 units. And in terms of numbers, it is equals to 3.755 units. And that is actually the answer to our question. The length of side AP that is equal to x, it is equals to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, it is equals to 3.755 units. Okay, thank you very much.